Hello viewers and my dear students. Welcome to session 2 on problems on analysis of beams. Then in this session 2, I'll be showing you a demo on simple beam supported at the ends subjected to transverse loading at the center using Ansys Release 14 of Mechanical APDL. As you know, we already started in session 1. Session 1 I have covered mainly the theoretical aspects of it, and in the session 2 we'll continue. That is, in session 1 only, to some extent we have started with the problem using Ansys. Now we will continue the problem and Ansys in this session also. See here, at the end of session 1 we had created two lines, and as you know, this entire thing is steel and this span is 4 meters and this is 2 meters and this is 2 meters, and I created key point 1 0 0 0, key point 2 2 0 0, key point 3 4 0 0 and key point 4, that is 4 and minus 1. The significance of this I tell you later on. Okay, right now you worry about only this. Okay, now we have created this. Then you see here, meshing you do. Okay, meshing you do, and mesh attributes, picket lines, take this and just say okay. Okay, now there is no material, the two different materials and all that. There is only one material and only one real constant. That is, this real constant has been defined in the section only. Okay, that is beam 188 has a section, this and the section only I have defined 0.2, 0.3 and all that. Okay, now in here right now, don't click on pick orientation key point. Okay, be careful. This you don't click on this. Don't click on this. Just say okay. Okay. Then size controls you go, manual size you go, lines, picket lines you do, pick this line also, and say okay, and number of divisions you give 50. Okay, number of divisions you give 50. That means this is also divided into 50. This is also divided into 50. Totally you can get 100 elements here. Now I tell you, since we are interested in bending stress also, please observe in these problems, it is compulsorily you save at this point. Save dB you do compulsorily you save dB. Okay, so that when I resume dB, I'll come to this stage. Please understand, we have not even made this as elements. Okay, we have just converted this into 50 divisions, this 50 divisions. At this stage only, I have saved dB. In case later on, if I say resume dB, I'll come to this stage only. Okay, now what I'll do, then mesh, lines, pick call, or select these two lines. Pick call you do. Okay, once you do, here 50, here 50, totally 100 elements you should have got. You just see list elements if you do. Okay, see here, this is elements. If you say 100 elements you would have got. Is it okay? 100 elements you would have got. Okay, this is up till here, what we have done is correct. Then meshing is over. Then what you do now, then you start loading. Loads, see here, it's loads, define loads, apply, structural, displacement, on key points, you click this point, and say okay. Okay, here you arrest all degrees of freedom. I tell you, see here, rotation X, rotation Y, except rotation Z. Don't arrest this. You arrest all other things to 0. Arrest all other degrees of freedom except rotation Z. You will know the significance of this shortly. Okay, then you make it 0. Okay, because this is X, this is Y, perpendicular to this plane is Z. No? Then in case if the beam bends, no, because of the loading condition here, if it bends here, the bending has to be facilitated by rotation about Z only. Otherwise, this will also be arrested. That is why that slope for this bending you will get without arresting that rotation about Z. Okay, please understand, arrest all degrees of freedom except rotation about Z. Okay, then force moment on key points. Okay, you take this, say okay, and then here you take Fy. Okay, Fy, as you know, it is minus, because it is in negative. Okay, it is negative y, no, it is downwards. Positive y is this, negative y is downwards, minus 20,000 newtons you give. Okay, minus 20,000 newtons you give. Now once you do this, okay, now you see here, solution, solve, current load step you do. Just say okay. Okay, once you do current load step, solution is done, you'll get, close you do, file, close you do. Okay, see here, now what this is one very important thing, what you should always understand. Okay, what you should always understand, here I have loaded here. Okay, now you see this, I have arrested all degrees of except rotation about z. I have arrested all degrees of freedom except rotation about z, because I want the slope to be found out here and all that, because the bending will be this way and all that. But anyway, okay, now these things I will come to this later. Now you see here, now the solution is done. You see here, now as you see here, general post process if you go, okay, and element table if you do, define table, okay, add you do, these things you have to remember, because these things you are getting in element table, output definition table of beam 188. Element table, as I have done in the one-dimensional problems, in the element table for beam 188, under search if you give, what are the commands you have to give, you will know. For SMISC 3, apply SM by sequence number, SMISC 16, apply. That means 3 and 6 combination will give us bending moment diagram. Okay, in the same way, by sequence number, SMISC 6, apply, by sequence number, SMISC 19. Okay, that is, see here, 316 will give you bending moment diagram, 619 will give you shear force diagram. Okay, I'll just say close. Okay, now you carefully see what exactly I do. Now you see here, these are all the things what you have to clearly understand. Now you see here, as you know, plot results, contour plot, line element result, SMISC 3 and 16, if you give this, you should get the bending moment diagram. And as you see here, 19,800 is the maximum bending moment, but actually speaking, you should get 20,000. As you see here, it should be 20,000 Newton meter. But in this section, I have got 19,800. That is why I have divided into 50 equal parts here. 50 here, 50 here. If you had made 100 and 100, almost this would have been 20,000 Newton meter only. That is why I have divided 50 here and 50 here to make you show that this is 19,800, which is very close to the answers what I have got by theoretical means. That is 20,000 Newton meter. Okay. Now this is that. Okay. In the same way, line element result. Next you go 6 and 19 you go. Okay. 6 and 19. If you go there, you are getting a shear force diagram. You see here it is perfect. It is red is 10,000. This is minus 10,000. And it is exactly matching with your theoretical thing. 10,000 and minus 10,000. In that way, it is correctly matching with the theoretical values. And also, I'll show you now RA and RB. They are these are all the supports, not A and B. They are the supports. And at supports, you have RA 10,000 newtons, RB 10,000 newtons. Okay. Now you see here. I'll go here again. Okay. Okay. Now you see here, list results I'll go, reaction solution I'll go, all items if I go here, see here, at node 1 and 52, it is 10,000 and 10,000 in the direction of y, because y is this direction, okay. That is, this is 10,000 and 10,000. See here, I'll do plot elements. These things you see here, as I've said here, before that, I'll tell you once again, plot results, you've done, no? Contour plot, line element results, 3 and 16. 3 and 16 will give you bending moment diagram. This has to be recorded, shown to the examiner, and even you have to write it in the record. And for that, plot controls, write meta file, invert white and black, and it will be copied in paint, and you copy that. Okay, this black will be white and this will be there. This is one of the things which has to be shown to the examiner compulsorily. Okay, in the same way, line elements result 6 and 19, if you go, you are getting a shear force diagram. This also, plot controls, write meta file, invert white and black, you do, again it will be saved, and this also will be saved in paint, and again this also you take the printout or make a copy and paste it in the Word and get the printout of commonly. Okay, this also is another very important thing. Bending moment diagram, shear force diagram, both you need to know. Okay, this you have to paste it in the records also or write it manually. That means bending moment I have shown, shear force diagram also I have shown. Okay, now you see here, once this is all done that, then you see here, list results, reaction solution if you go, all items, you see here, at 1 and 52 it is 10,000, 10,000. See here, now what I'll do, I have all got plot elements I'll go. Plot elements I'll go. Okay, once I got plot elements, plot controls, numbering, node numbers on I'll do. I'll say okay. So many node numbers I got. Okay, you know very well, the first should be 1, the last should be 52. At least we'll examine the last one, whether it's correct or not. You see there is one zoom model. You zoom at the end. You see here, can you see? The last node is 52 and the 52 it is 10,000. And the first one also, you fit it. If you expand this, okay, if you expand this, it will be 1 only. This will be 1 only. At 1 and 52 on last node, 10,000, 10,000 in the upward direction because I have given the force in the downward direction. Then I'll fit this and plot controls, numbering, node numbers, I'll switch it off. I'll say okay. Okay, now I'll come to this same stage. Now this also is one very important thing. Okay, what you have to record and show it to the examiner. Okay, this also is very important. Now what I want you to remember here is this you close. Okay, this you close. See here. See the now what you see here is plot controls, style, size and shape. Okay, if you display on, okay if you do, and if you make an isometric, you see here x is this, y is this, the beam is not in the proper orientation. Okay, it has to be properly oriented because plot, multi-plot if you do, the loading actually in the y direction, no, I have applied in this direction. That is why the orientation is not proper here. Irrespective of the orientation, this bending moment and shear force diagram will be same. But actually the bending, no, maximum bending and all that, orientation has to be proper. This we will take care in the next session, that is session 3 on beam analysis. Up till here, the beam orientation is not at all important. Now in order to get the correct displacement due to load, you need beam orientation. That we'll do in the next session. Thank you very much friends for watching. Thank you very much. We'll continue this in session 3.